Well, welcome back to day two. Today we're looking at the ion charge and formulas of ionic compounds. Now this is going to be today's going to be a little bit more involved than last day. So, so pin back your ears. We're going hard. Okay. Let's begin with getting some notes down. So elements combine, but not always the way we want them to. Where's my pen? Alchemists believed that they could combine any element any way they wanted to. Alchemists combine any element any way they wanted to. For example, when sodium and chlorine combine, they always form NaCl, not NaCl2 or Na20Cl. So when sodium and chlorine combine, they always form NaCl and not NaCl anything, 3 for example, or say Na3Cl. It just doesn't happen that way. French chemist named Joseph Louis Proust proposed a law of definite proportions in 1799. So French alchemist named Proust, Proust. Oh, proposed the law of definite proportions. And the law of definite proportions states that a specific compound, A, I need to move that, a specific compound always contains the same element in definite proportions. Always contains the same elements in a definite, you can think of this, unchanging proportion. Early alchemists understood elements combine, but they didn't know why they combined in specific ways. They did not know why they combined in specific ways. Now, just as an aside here, please don't make the mistake of thinking that if I have hydrogen and oxygen, they will always form water in a 2-to-1 ratio. You're implying something backward now. Water will always be a 2-to-1 ratio. But hydrogen and oxygen can also combine in other ways. So this is always water. But there is another critter out there, and you may have this in your medicine cabinet at home, where this is a 2-to-2 ratio, and this is always hydrogen peroxide. So the law of definite proportions, it says if you're talking about water, it's always 2 to 1. But it's not saying that if it's hydrogen and water combining, it's always going to, or hydrogen and oxygen going to be combining. It's not always going to be water. You're not saying that. Okay. I know that's a bit of a mind bender, but when in older grades especially, you'll see that there is another law in play too that says that's the law of definite proportions, and there's another called the law of multiple combinations or something like that, so that oxygen and hydrogen can combine in other forms. Okay. Recall, a metal and a non-metal will always combine so the compound formed is neutral. So, okay, so recall, a metal and a non-metal will always combine so that the compound they form, that is formed, is neutral. Toothpaste is sodium fluoride, and that contains so sodium has a charge. The sodium ion has a charge of +1, and the fluorine ion has a charge of -1. So when they get together, the total, think of this as +1 and -1. If you add those two together, this becomes, oh, wrong thing. This equals 0. So that means that this is no charge. It's neutral. Okay? Predicting how elements will combine. Knowing the ionic charge makes it possible to predict how the element will react and form compounds. Okay? When ionic compounds form, every electron given up by the metals must be accepted by non-metals. So when ionic compounds, oops, I'm off the page now. When ionic compounds form, every electron given up, that would be by the metals, hang on. It's Jamilo. Hi, Jamilo. No. No. Actually, one of the blues should go to Jacob Lucky. Yep. No. Yeah, one of the blues. I'm sorry, say again. That's for physics. Physics. Oh, yeah. Yeah. Yep. Okay. No, yeah, because I was anticipating doing the stuffing myself. Yeah. Okay, thank you. Bye. Don't you just love her? Jamila's the best. So, here we are again, when ionic compounds form, every electron given up by the metals must be accepted by nonmetals. So example, I'm combining Na, sodium, and say the sulfide ion, which is 2 minus. How many atoms will I need? How many sodium will I need? And how many sulfur? So right now, I'm going to show you a cheat. It doesn't always work, and we're probably going to do this again, but there is a YouTube video embedded in your PowerPoints that you should watch. You should watch all of them. So once we finish here, go through all of the PowerPoints and find those YouTubes and click on them. So basically, the trick is this. You write down the metal, and you write down its charge here, +1, and then you write down the non-metal, because it always goes second, and 2 minus, like this. Now at this point in time, the plus and the minus only tell you which one to put first. The numbers themselves don't make much difference. So how you do this is the cheat, it works most of the time, is you take this number and you put it there. Then you take this number, jump over the line, and you put it there. So what this will look like would be Na2S. Okay? Now, the reason for that is that if this guy's only given up 1 electron, and this guy wants to gain 2, then I need 2 of these guys to provide both electrons. The other way that you can think about this is something called combining capacity. And how we imagine this is not true. The combining capacity, those are like hooks. So however many hooks you need will be given to you by this number. So if you think about sodium like this as having 1 hook, so I have sodium and he has 1 hook. Okay? Sulfides, they have 2 hooks. Now the law says that when you form a compound, all the hooks have to be hooked to something else. They all have to be hooked 1 to 1. Okay? Now, if this is going to be true, I can hook this guy to here. This is no problem. These 2 guys can hook together. But what's going to happen with this guy? He needs another sodium. Now, so I'm going to put, I'll put him like he's hooked up already. Like this. And this one comes in. So we're looking at just looking at this now. So this is what it's going to look like. You're going to have 1 sulfur in the middle, and you're going to have sodium on each side. And this is actually what happens. Okay? So this is Na2S, just like that. Okay? Balancing charges and equations. Okay, let's do this right now. Combine aluminum, which has a plus charge of 3, and an sulfide, which has a combined capacity of 2 minus, and tell me what the formula is. So, the first thing you do is write the metal and the non-metal in their ion form. So write the metal and non-metal in their ion form. And I want you to do that right down here right now. So do it. Pause if you need. Then write the metal and non-metal again without their ionic charges. Okay. Bring the charges down by crossing them. Bring the charges down. Done. By crossing them. Okay? And the last one is reduce if possible. And then that I'll show you one later on. Reduce if possible. Okay? So pause, do it, and then come back. Okay, I'm going to assume that you've paused, you've done this, and you've come back. So this is what would have done. Step 1, I would have written like this: Al 3 plus S 2 minus. I'm going to write them down here again. And on this one here, I'm going to bring the charges down. I'm going to bring this down to here. I'm going to bring this down to here. So the first one, bring the L down to here. So I'm going to put a 3 there. And then I'm putting 2 there. Notice there's no pluses and minuses, okay? And that's it. That's what you should have. Okay? Now what I want you to do is I want you to do these ones on your own. Okay? I'm not going to do them now. I'm going to get you to do this on your own. Okay? So pause, do them, and come back. Okay, we're moving along. Polyatomic ions. Recall that a polyatomic ion is a group of elements that act as a unit. It's a group of elements that act as a unit. Follow the same steps as listed above. Okay, I'm going to do the first one, and I'm going to let you do the next two. So I'm going to do cesium plus 1 and CO3 2 minus, or minus 2, doesn't matter. Okay, so CS CO3, I'm going to take this, it's going to go down here, this, and there. So the 2 is going to go here, and this is going to be a 1. But because it's only 1, I do not put brackets. I only put brackets if there's 2 or more. So CS2, CO3, is going to be this one here. Okay? I want you to do the other ones on your own. And if you have trouble, get a hold of me at my office hours, and I'll help you with that, okay? Okay. moving along. Multivalent metals. Ooh, now it's starting to get interesting. Most metals have one charge. And they're called monovalent. Mono means one. Valent refers to the number of electrons in the outer shell. So they only have one set number. But some metals have multiple valences. Meaning more than one possible scenario. Okay? And these are called multivalent metals. Okay? These are metals that are after the first 20, and it is caused by the ability to be stable with different numbers of electrons after the first 20. So first 20 is up to calcium strontium, I think, and it's first 20, and it is caused by the ability to be stable with different numbers of electrons. Different numbers of electrons. And we normally use Roman numerals to tell you what their ion charge is. Okay? So we're going to use the same steps as above, but in this case we don't even actually have to look at the periodic table to find out what irons is. But step one is to write down, so I'm going to do iron 2 hydroxide. So my suggestion is this: we're going to divide this into spaces. Okay, so 3 spaces across. And I'm going to do the first one here, and this is going to be iron 3 hydroxide. And I will get you to do on your own iron 3 hydroxide and lead 4 sulfate. So iron 2, I look at my periodic table. If I can't remember my my ions now, iron is Fe. This number here in Roman numerals tells me that this is +2. Hydroxide, from our table, we know is OH minus. So now what I'm going to do is I'm going to take this one here, I'm going to bring it down to this, to be the subscript. We call this the subscript for the iron. I'm going to take this one here, I'm going to take it down to be the subscript for the hydroxide. So this is going to look like Fe brackets OH2. Okay? So I want you to do the other two, and then we will, and then you're going to be fine. Let's see now. 242, homework 242. Explain the different. I don't even understand that question. Explain the different properties of copper 1 and copper 2. basically, I'm going to do that one with you. Actually, the first two. Explain the different properties of copper 1 and copper 2. Basically, all properties are the same. The difference is in their ability to form bonds. Copper 1 can form one bond. Copper 2, two bonds. And the same basically is here. How do you for iron 2 and iron 3? Iron 2 can form two bonds. Iron 3 can form three. How do you recognize the difference between the ion charge of a metal and an ion charge of a non-metal? The metals are always positive. Non-metals are always negative. Okay, now I think the rest. Okay, so that's about it for there. We have two pieces of worksheets that I want you to do. This is going to be your homework. This is for reals homework. Okay, you should be able to finish this within. We've only been working for 27 minutes right now. You're going to be having a couple of videos, and so this should round out your day. So it says write a chemical formula for each combination of ions. So 1 calcium, now it's telling you how many. So that means that I'm going to have 1 calcium, and I'm going to have 1 carbonate. So this is going to be 1 to 1. This is going to be CaCO3. The next one, 1 lead and 2 nitrate. So you're going to need your periodic table, which is in the back of your package, and your polyion table, which is on the reverse side of your periodic table, and 1 lead and 2 nitrate. Nitrates are NO3s, so it's 2 of them, so I have to put those in brackets, like so. So I've done the first 2 for you. So I want you to finish the rest. These I want you to make sure that you write your name in the top. Okay? Maybe do that now. When you then take a picture of this and text it to me, or take a picture of this and email it to me. Okay? I want to see that. The next one for today is to write the formulas. Write the formula for the compound zinc. These guys here. Now this is going to take you more time. Maybe what I'm going to do is I will lead you through a couple, and then I'll show you how to do a couple, and then I will leave the rest to you. So you're going to need, again, your periodic table, which is at the back, and on the other side is these polyions. Now, you can use just this sheet by itself to do these examples. It's also good, though, for practice to find them on here as well. Okay? Okay, here we go. Let's use this one, though, for now, because I think everybody will probably use it. You should have this beside you, because I'm not going to be flipping it back and forth. Okay? Zinc bromide. Zinc, I find, it's a metal, so it's going to go first. So zinc, and it has a combined capacity of 2 plus, and bromide is a Br. It's a nonmetal, and it is -1. So it's Br. This is -1. So I do the switch, and you know what's coming. This is going to be, that should be Br. Sorry. It's going to be Zn Br2. Sodium oxide. Sodium is a metal. Has a ion charge of +1. Oxide is a non-metal, -2. I'm going to do the switcheroo, and so this is going to be Na2O. Lithium hydroxide. Okay, now this is where you have to be a bit careful. Hydroxide is in the polyatomic ion list, which is in the bottom left-hand corner. So lithium is a metal, has a +1 charge. Hydroxide is down below it, you should find it, and it is OH, and has -1. So we do the switch. It's a 1-to-1, so this is going to be lithium hydroxide. Okay, so let's see now. Let's see if there's anything other that's really interesting. Oh, let's do this one. Magnesium oxalate. Magnesium, Mg, is +2. Oxalate is C2O4, -2. Now, if you follow the rule strictly, you put a -2 here and a +2 here. Do you remember earlier on I said what we're going to do is you have to simplify if possible? Well, in this case, you do have to simplify. And I'm going to walk through it on this little tab here. So if I took that down here and that down here, this would become Mg2 C2O4 2. Okay? These ones here I can simplify. Not these ones. I leave those alone. You can't play with these ones. You're not allowed to play with. The only time that you are allowed, the only subscripts you're allowed to play with are the ones that you brought down, not the ones in the ions. Only these ones that you brought down. If I divide both those by 2, this becomes Mg C2O4, and that will be the right answer. This is okay. I'm going to leave this to you. I think that at the beginning of the next class, no, somehow we need to do this together. I'm going to ask you to complete this whole sheet. If you have questions, I suggest you do this today, okay? Between now and this afternoon, do as much of this as possible. The ones that you can't do, I will have open office hours after 1 o'clock today. So what I'm going to do is I will send out an invite, a Zoom invite that you can all come to, and we will do this in Zoom. I'll help you in Zoom, okay? And yeah, I look forward to seeing you. So love you, and that's it for now. Love you, and go away.